Welcome. Let's solve Leetcode 1800. Maximum ascending subarray sum. All right, let's make this bigger so we can read it. Alrighty. Given an array of positive integers nums, return the maximum possible sum of an ascending subarray nums. A subarray is defined as a contiguous sequence of numbers in an array. A subarray nums L plus 1, all the way to nums r minus 1 nums r, is ascending if for all I where L is less than or equal to I is less than R, and the value nums I is less than nums I plus 1. Note that a subarray of size 1 is ascending. Alrighty, let's go over example 1. So in this example, we have this here. In particular, we have this, and they expect the result to be 65, being that these first three numbers are ascending, which would be a subarray of a grand total of 60. However, there is a separate subarray of these three values that gives us 65. Hence the expected result is 65. In this, and for example 2, the entire array provided is ascending. Hence the expected result is the sum of all the elements, which is 150. And lastly, in number 3, in example 3, it looks like 10, 11, 12 is the largest subarray within the nums array, which gives us a total of 33. Alrighty, so it seems like the problem's straightforward. Let's go over how we'll do it. It should be rather straightforward. What we'll do is we'll keep a count, and as we loop through the array, we'll add to the result if the next number is greater than the previous. Otherwise, we'll reset it. So let's kind of go over that here. So we'll say maybe current, and we'll say max, and we'll set them both to num0. So we're guaranteed that there's at least one number. So we know this is true. And just to make sure we don't forget, we'll return the max now. And what we'll do is we'll loop through our array. So we'll say for I in range. Now, notice how we already started with index 0, so we don't need to start from index 0, so we're starting at 1. And we can move on to the next, the remainder of the array, or list. And now let's check if this next number is bigger. So if these two adjacent numbers, if the next number is bigger, then we can add it to our current. Otherwise, we'll reset current. And now for every number we encounter within the list, we'll check if this current value is bigger than max. So we can say current equals, max equals the max of max and current. Okay, let's test it. Okay, looks good. And let's submit it. Okay, looks amazing. If we wanted to discuss the time complexity, since we're only looping, we only have one loop here, which is dictated by the size of the input, and there are no inner loops in here. the time complexity would be O of n. Maybe I'll just write that down here. And then as far as space, so we only have two primitive variables that are storing integers. In this case, we're just comparing elements already in the list, so there's nothing going on here. We're not using any extra memory here, and this is just a function call. If we wanted to, we can remove this, but we're already at, well, let's see, we're at 7.86. This wouldn't affect the memory that we're using, so if anything, it would add to the time complexity. So space is 001. We're only using two new variables here, and that's it. Okay, so let's try also solving it in C++. All right, so let's begin. So let's initialize our current value. So we'll say the int current. We'll set this equals to nums. I think there's a front here. I think we'll just go, yeah, okay, we'll just go the safe route, and then afterwards we'll try with using the vector methods. And then we'll say max equals nums. Okay, and then we'll return max. And we'll do as before. We'll loop through the array and compare if the new number is bigger than the previous number. So we'll say for int I equals 1, because remember we're already using the first value. I less than nums dot size I plus plus, and then we'll say if nums I is greater than nums I minus 1. Well, we can add to current. Otherwise, we'll reset it. And lastly, we'll check if max has been updated. So we'll say max equals max of max. And let's test it. Okay, looks good. And let's submit it. Okay, I think I just want to try this out. I think a vector has another method called, I think, front. Let's try that. Okay, and maybe same thing here. And we can submit it. It won't make a difference. We're already at 0 milliseconds for time complexity. But sometimes I just like to explore other options at our disposal. So that's why I did this. But it's not necessary at all whatsoever. In addition, I think there's a pop front. But in this case, this is fine. All right. If you found this video helpful or educational or beneficial in any way whatsoever, please consider liking or subscribing. Other than that, have a wonderful day. Take care. Cheers.